But again, I will solve it first thing next week. That one I will solve first thing next week. What I want to do right now, since the majority of the people here are, their backgrounds are extremely
Yes.
I want to do a final problem, a final category of problems.
I'm so confused.
Again, everybody please take your
And I'm
seats.
always
I want
fresh.
to do a final category
Like my
of
feet sweat a lot.
problems
So.
that can be solved using linear programming. And now I've selected a group of problems from the healthcare industry. So let me put some numbers on the board. So it's a completely different group of problems. Again, everybody please take your seats. So I'll give you a completely different group of problems. So we are... I will continue with personnel scheduling in class next week. So right now, what I want to do is I want to put a completely different group of problems. So the next group of problems is the balanced diet problem. Okay, everybody please. Again, this is not in any textbook, so I need you to pay attention in the presentation here in class. So the next and final group of problems that we're going to cover in this class that can be solved using linear programming are the balanced diet problem. So let me give you, I'm going to use, I don't want to promote products, I'm going to use generic terms. So let's assume we have diet supplement. So let's assume we have diet supplement A. Let's choose 3 of them. C. So we want to supplement our diet and we have 3 different choices, A, B, C. So why do we want to do that first of all? Because we want to have on our daily diet at least the minimum quantity that we need of certain nutrients. So again, the nutrients can be carbohydrates, can be minerals, can be whatever, but I'm going to use generic terms. So let's call them nutrient 1, nutrient 2, let me use 3 of them. So what is the information we have? So if you take this, so 5% of its weight, I'm just putting numbers here, of A. So let's go A, B, C. For A, 5% of its weight is nutrient 1. Let's put 10% here and 20% there. The next one, let's put 30%, 8%, 3%. And the last one we put 12%, 9%, 14%. Okay, so these are, again, on a daily basis, we can take a daily basis and we say, for having a healthy diet, for certain nutrients, we can call them, as I said, any specifics you want, but we say we need to get, if we take this supplement, diet supplement, 5% of its weight is nutrient 1, 10% of its weight is nutrient 2, 20% of its weight is nutrient 3, and so on. What are the minimum requirements that we have to have? So let's assume a balanced diet requires the intake of at least 100 grams of nutrient 1, 150 grams of nutrient 2, and use 100, 150, and say 80 grams of nutrient 3. So what is the question? What is the minimum amount of diet supplements that an individual should take to satisfy the minimum basic nutritional requirements. Again, I use very generic terms here. So let's assume we have a choice to take 3 different diet supplements, A, B, C, any amounts. And then we say, here is the information we get. A, 50% of its weight is nutrient 1. 10% of its weight is nutrient 2, 20% nutrient 3. The same value, different values for B and C. So there are 2 versions of this problem. So this version here, there is no cost. I assume each one of them, A, B, C, cost the same amount of money. Then I'm going to generalize, I'll give you a cost version. So right now, what are we trying to do? What is our one objective? One objective is to satisfy the diet requirements by eating the least possible amount. That's the problem, the version of the problem that I solved. So obviously, we can get there if we eat tremendous amounts of those different products. But the first objective here is how we can get there, to satisfy the minimum requirement, to satisfy those requirements, by eating the least amount of food. So, believe it or not, this problem, this is a snapshot of a more general problem called the balanced diet problem. So let me solve this problem for you, formulate it, and then solve it. And then I'm going to give you as an exercise a generalization, which is we're going to factor in the cost. Because right now I'm not factoring in the cost. I'm trying to see how can we get there by eating the smallest amount of food possible. So let's see what our variables are, because that's the data. So obviously we need to figure out first the variables. So remember, some of you say, why are you always using x1, x2, x3? So let's use xa, xb, xc. So right now, since the 3 different... No? Okay, we'll leave the numbers. Okay, x1, number of grams of diet supplement A. So we have to decide how many grams of each one of them to eat. So x1 is how many grams, number of grams of diet supplement A. Obviously, 2 and 3 will be very similar, B and C.
8.
Okay, so the variables. How many grams of diet supplement A is x1? How many grams of diet supplement B we should take is x2. And x3 is how many grams of diet supplement C. What is our objective? The minimum total food intake. So the objective is to minimize x1 plus x2 plus x3. Remember, why is this? Because I said minimum amount of diet supplements, minimum amount. So x1 grams of A, x2 grams of B, x3 grams of C. So the objective is to eat the least possible amount. So that's the objective. Minimize x1 plus x2 plus x3. Constraints. So how many constraints do you envision here? 3 constraints. 1 constraint per nutrient. So nutrient 1, look at what we say for a balanced diet. Where is the number?
100 grams.
So we need at least, let me finish and then I'll answer the question. We need at least 100 grams of nutrient 1. So, if we eat x1 grams of A, how many grams of nutrient 1 we get? 5% of it, 0.05 x1. So, 0.05 x1
times 100.
Plus, remember, we eat also B. B is richer, 30%. 0.3 times x2.
Because you have to add.
times this one.
You don't have to put it there.
Is it clear to everybody that it's
Yes.
multiplication?
Multiplication.
You can just do the parentheses.
As long as it's clear, I don't have a problem.
No, that makes problems.
5x1 plus.
No.
No, it was better here.
That's worse.
Okay, it's okay.
Thank you, Professor.
This is multiplication.
Oops.
Okay, look at how the constraint writes. Okay, look at what I did. Look at the column. Nutrient 1. If we eat x1 grams of A, how many grams of nutrient 1 we get? 0.05 times x1. If we eat x2 grams of B, how much do we get? 30%, 0.3 times x2. And if we eat x3 grams of C, how much are we getting? 0.12 times x3. All of this together, we need a minimum of what? 100 grams. That's how it works. So that constraint is telling us, I don't tell you exactly how many x1, x2, x3, but the combination of the three, combined, added, you must get at least 100 grams of it. Now you can guess how I'm going to write the other. How many more constraints do I need? Two more.
Two more.
One for nutrient 2 and one for 3. So for nutrient 1, I'm done. So for nutrient 2, look at the number, the key number, 150. So I need 150 grams of the second one, nutrient 2, 150 grams. Look at how I'm going to get there.
Mira, pero eso es bastante.
This column. That's how I'm going to get there.
Entre
This
38
one.
personas.
0.1 times x1 plus 0.08 times x2 plus 0.09 times x3. How
Diego.
many of these I need daily? At least one.
Diego. You're suffering? You're suffering.
Now, if you make a mistake, let's assume when you type, you're in a hurry and you make a mistake, you put less or equal here by accident. If you make a mistake and you put less or equal, what is the solution?
0.
Zeros. You're not going to get anything. Because if you say less or equal, you say, I can live with zeros. You see, it's a less or equal, that's the reason, at least, you need at least 100 grams. Because if you put less or equal, the computer understands that even 0 is acceptable. So if you yeah, exactly. You get zeros. If you allow zeros, nothing's going to happen. The last one, 0.2 times
0.3.
x1.
0.3.
0.03. 3% is 0.03. Okay, be careful between
Sure.
30% is 0.3, 3% is 0.03.
Yes. 0.14.
What is the value here?
80.
That's it. So you see, now what I want to do, I want to, make you aware what type of diverse problems can be solved by the same type of techniques. So this problem is completely different from business optimization. This is coming directly from nutritional sciences. So this is called, there is a generic name for this. This is called the balanced diet problem. Because what is the objective here? The objective is to achieve a balanced diet. What is the definition of the balanced diet? The minimum amounts of those nutrients. So we need 100 grams of this, 150 grams of that, 80 grams of this. And we want to take foods which are going to get us there with the minimum amount. So in this version of the problem, I treated A, B, C as costing the same. What is missing here is how much money is costing us. So indirectly, I treated all three of them, A, B, C, like they cost the same. That's a simplification. So I assume there are three different products out there, and each one of those products is costing the same. So if cost is not an issue, what is the objective? To get there, to get the diet you want by eating the least amount of food. That was the way. That was the objective.
What's the real life application?
The real life application is to get in dietary supplements. There are products. Let's assume your doctor says you are deficient in let's use one of those that is
Iron.
iron. Thank you. Iron is a good one. And you say you need a minimum, let me finish. You need a minimum amount to get there. So you can say, let's check vegetable. Let's use one variable, iron. Iron is the only issue you have. And you want to get there eating natural food, not eating medicine. So you say, let me check certain types of foods which are heavy on iron. So you can do this research to say broccoli for now may have 10% iron. Or this one may have 20% iron. Lentil, I think it's good in iron. So you can work this out to get the minimum amount of iron you need without taking into medicine. Or if you get into medicine, I'm going to show you the version where we put cost. But this problem is what we call a balanced diet problem. No, this is what Okay, let me have your attention. So what I'm going to do is I'm going to give you a generalization of this version to factor in the cost as an exercise for next week. So it will be a very direct extension. So all the numbers that I have here stand. There's going to be one change on. So all of these numbers stand. But in addition now I'm going to introduce costs. So let's assume. So all of these numbers stand.
Susie, how's it going?
Diego, it's gonna be okay.
No, yeah.
Yay. Yay, that's my peluche. Great, I'm glad you got it. Oh, come on. Oh, sí, el calor. Yo tengo mucho calor. I'm not sweating, but it's... Déjame que... ¡Ay!
And all of these are integer, right?
Yes. No, in this problem, because remember, we're talking about fractional numbers. We don't need integers because the solution may be 2.5 grams. It's acceptable. Yeah, it's not. Okay, this is again, this is the homework problem for next week. So let me again tell you a hint, a very strong hint. What is the change between the version of the problem that I did minutes ago and the one I'm asking you? The only change is the objective function. The constraints are going to stay the same. In the previous version, the objective function is to minimize the amount of food. Now what are you minimizing? The cost.
Cost
so it's very simple. So you're going to take this.
Times quantity?
Yeah, you're going to take this and you're going to put numbers before 1, 2, and 3. It's a very trivial extension, but I just want to let you know that there are two versions of this problem. One version of the problem is if you treat all supplements equally, but in real life, some are more expensive than others. When it comes to food, not all types of food cost the same. Alright, we're going to have one more. We're done with linear programming problems. Okay, I need everybody's attention, please. So as I said, we are finishing the first main topic in this class were linear programming problems. So, as I said, you are responsible for the front end, which is to formulate problems, and the back end, when I give you a solution, to be able to interpret the solution. On the formulation part, besides writing down the objective function and the constraints, you may be asked to answer in some cases if there is dominance, like we did today. On the back end, when you are given a solution, the main objective is to figure out in that solution which constraints are binding, and for the non-binding constraints, where we have, how much slack do we have, and so on. So that concludes, as I said, all linear programming formulation problems. There are three categories, general categories of problems. The first one was resource allocation. The second one, that we finished earlier today. The second one was personnel scheduling. Third and last one is an industry specific, coming primarily from the type of industries you are working in. It's called the balanced diet problem. So what I'm going to do now, last week when we passed the handouts, I think one of the handouts that it passed was aggregate planning. So let me make sure, let me give you some information first. Okay, what I'm going to do, because we have almost 45 minutes, I'm going to introduce, but I'm not going to finish the next group of problems. But as far as linear programming formulation problems, we are done. So as I said, one more time, resource allocation, personnel scheduling, and balanced diet. So next week, you have only the homework assignment of submitting the generalization of this problem, which is the cost minimization version, and the personnel schedule. Yes.
Excel or just Excel?
No, on this one I want you to try to solve it in Excel, because it's a homework problem. Yeah, solve in Excel, but solve not this version, the version that I'm asking you. For example, here, I want the solution where you put the cost. And in the previous one, in the personnel scheduling, the solution again but minimizes the payroll cost. What I'm going to do is I'm going to change shifts right now, to change gears and go into one different category of problems. I'm going to just start it today. But again, I need your attention, because it's not going to be a problem for which you have access to a textbook. So I'm going to just give you a presentation here, a small presentation today, and the rest of it is going to be done next week. So let me erase this one here.
Ay, me asusté, sorry. ¿Qué pasó? Bueno, nada más hay 14. On?
What did you get down?
One more
Which
thing before
one?
I continue. Did you?
Oh, I
I
haven't
asked you
done it.
last
But
time
it's
and you
easy.
told me
It's just
you were supposed to
yeah.
distribute a case study,
Okay.
Harvard Business School
No,
case.
I'm not.
Have you received that or no?
No.
Okay, why don't we pass it?
I'm not using Excel because I'm recording.
For next week, not for today. This is for next week.
Qué calor tengo. Yo creo que
Okay,
la gente
so
no
what
se
I want to
calor.
do is I want to give you the introduction of the next topic, and the next topic
Yo creo
is
que la gente no suba.
production
No,
planning.
todavía no me estoy quemando, pero I'm close to.
So the case that is being distributed is for next week. So go ahead and as a reading assignment. Read it, but we're not going to
that
cover
another
any
one?
material from it today. So this is for next week. So just keep one copy just to read it, and we're going to work on it next week. So what I want to do right now is I want to give you a general introduction of production planning, and the details also is going to be covered next week for this one as well. So what is production planning? I just want to give you a general introduction to this. So production planning traditionally was related to manufacturing. But obviously, as I said last week, the techniques that we were used to use for manufacturing problems also apply to service industry problems. And production planning is an easy task if the demand for our product is stable. So let's assume we have a pattern. So this is the simplest possible demand pattern. So this is time. This is demand. Okay, look at the simplest possible case, demand as a function of time. It's flat. So demand is the same. So as time goes on, demand remains the same.
But,
So from a production planning standpoint, again, be quiet. From a production planning standpoint, that's a very simple problem. Let's assume demand for our product is the same. It doesn't have to be a manufactured product. It may be a service. So let's assume every day, if it's a service industry, we see the same number of customers. We see the same number of customers. They require the same amount of time per customer. So that's a simplification and oversimplification. In a situation like this, we say that the production planning problem is very simple. If we know that we see every day the same number of customers, let's say 50 customers, and each one of them requires 10 minutes of attention, we can figure out how much service time we need, and we say this number remains the same throughout the year. So what do we have to do from a production planning standpoint? We hire enough people and we say, well, with 10, 15 people, however we need, every day in and out we have the same amount of demand. So we need the same number of people, employees, to serve those customers, and the problem is trivial. However, in real life, as you know, this is not the case. So regardless of whether you are in a service industry or in a manufacturing environment, demand fluctuates. And it's the fluctuation that creates a challenge with respect to production planning. I'll use the simplest possible version of fluctuating demand. So let's assume demand fluctuates between two different levels. So in real life, of course, it's more complicated, but I use this as a starting point. So let's assume that demand fluctuates as a function of time between two different levels, high, low, high, low. So what I use the simplest possible fluctuating pattern between high and low, and so on. So in this case, if we have a situation like that, there are two different schools of thought as far as how to plan to satisfy this demand. So there are two, as I said, two different schools of thought. One school of thought says, well, let's fluctuate the workforce, assuming we have the flexibility of laying off and hiring people back and forth. So each time our production capacity matches the demand. So in that case, the plan is called a matching production plan, or a synonym is a chase demand plan. Matching and chase demand are synonyms. What do they mean? They mean that no matter how often we have fluctuations in the demand, we fluctuate our workforce. So if we need 10 people today, 20 tomorrow, 10 the day after, let's assume our employee needs alternate between 10 and 20. We say no matter what is the cost, we're going to have 10 today, 20 tomorrow, 10 the day after, 20 the day, and so on. It's a philosophy. Sometimes, of course, it's unrealistic. You cannot have people come and go like that all the time, but theoretically it's an option. So this is one option where we say we cannot afford to have inventories, or in some cases, if it's a service, we cannot have inventories. So we cannot inventory our capacity. So we match the demand. So we go high, low. If the demand goes high, low, then what we do, our personnel staffing goes high, low. What are the advantages and the disadvantages of this plan? The advantage is that we don't have any inventory, no inventories. Exactly, we have only exactly no inventory cost, but the disadvantage is that we have hiring and layoff costs. Some people may question, is there a hiring cost? Yes, it is. It's training. When you hire people, even if you rehire, you have to go through some training. And the layoff cost sometimes is severance. If you have employees who have been working for some time, you have to have a severance package. So that's a disadvantage. But the advantage is that you run this factory, if it's an industrial operation, you don't have any inventories. You just produce what you need, then go high, low, etc. That's one school of thought. The other school of thought is to say this is too expensive to fluctuate the workforce back and forth. The other school of thought is to say where is the average? Somewhere here. So I'm going to have a production level which is somewhere in the average. And then what do? I use inventory. For example, during this time period, the demand is higher, but here the demand is lower. So during this time period, I produce more than we need. So I accumulate inventory. Then I take this inventory and I use it here, and vice versa. So that's a completely different school of thought. We say if it goes high, low, high, low, high, low, I'm going to produce in the middle. And then what I'm going to do? When it's low, I produce more than I need. I save it. I inventory it. When the demand is high, I make up the difference using the inventory. That's a completely different school of thought. So the blue line leads to a completely different production plan called level production plan. Or sometimes it's called a levelized. What are the advantages? So, what is the characteristic of the level or levelized production plan? A constant production rate. So the demand may be going up and down, but our production rate doesn't change. It's the same throughout. Now, in a manufacturing industry, it works. In a service industry, it may not work. Because in service, sometimes there is no inventory. How can you inventory service? Okay, so there is a limitation. Sometimes services become creative with this to inventory part of it, but sometimes it's not possible. So let's take the case of manufacturing where it's possible. But what is the advantages and the disadvantages of this one? The reverse of the other one. So this is like the reverse of the other one, of the matching plan. So here, what is an advantage? An advantage is no hiring and layoff costs. So an advantage, no hiring, layoff cost. And a disadvantage, inventory, exactly. So those are the two extremes. Now, somebody may say, there is nothing in the between. Of course there is. So let me give you examples where maybe the best solution is none of the above. Maybe the best solution is to try something which is a hybrid of those two. Sometimes the best solution is a hybrid. Who dictates, which factor dictates the selection of these? Which one of the two is better off there is a hybrid? The demand. So what we do, we always plot the demand. Let me give you an example by plotting a demand where the hybrid may be the best solution. So let's assume we have a demand like this. Let me tell you, if somebody's saying, is it realistic? Yes, it is. Let me tell you what are the little cycles and the big cycles. Those little cycles is what we call the seasons in the demand. It's when the demand fluctuates because of the nature of the product. To give you an example, if we are selling air conditioning units, the high lows are winter, summers, etc. What are the big ones? The big ones are the economic cycles. Remember, economies go through cycles. How long do they last? Several years. An economic cycle lasts 5, 7, 10 years. Nobody knows exactly how long they last because that's a question which economists spend a lot of time and money, but still we cannot get a precise answer. But it's a fact of life that economies go through cycles. So the big ones are the economic cycles, and the little ones are the seasons. That means the product exhibits some seasonality. Within the year, we know that there are certain months of the year where the demand is high, and there are other months where the demand is low. But this fluctuation may happen at high level if the economy is booming, and may be happening at a low level if the economy is in recession. So that's what I'm saying. An example is big cycles, economic cycles. Small cycles, seasons within the economic cycle. So what does it make sense here from a production standpoint? What it makes sense is the following. We say, for those little cycles, we may be better off to use a level production and have some inventory. But when it's going to go from all the way down to here, we have to make an adjustment. Lay off people, shut down some facilities, and so on. So let's go down, do this, and then up, and so on. So what is this plan? This is what we call a mixed plan or a hybrid. Why is this a mixed plan? Because it combines the characteristics of the other two. So this line, this one, is a mixed plan. A synonym for a mixed plan is hybrid. Why? Because it combines the characteristics of the other two. At this point, it's behaved like a levelized plan. But by adjusting here, it's behaving like a matching plan. So, yes, there are plans which combine the characteristics of the other two. So how do we figure out if somebody gives us, first of all, somebody's going to say, what is a prerequisite to figuring out what is the best production plan? We need to know the demand pattern. If we have no idea about the demand, obviously all of this is null and void. But somebody now may ask me, how do you know what's going to happen in the future? That's the reason we do forecasting. So in any legitimate business, people do, management spends time on forecasting. Forecasting is a prerequisite to accurate production planning. If you don't do forecasting, you're not going to be able to have any idea what's going to happen. How do we do forecasting? Two different ways of doing forecasting. One way is quantitative. We're projecting, we're using data from the past. And forecasting, quantitative forecasting, is to project the past into the future. For example, is this accurate? Well, if we try to figure out what's going to happen next couple of months based on what happened a couple of months ago, it's accurate. But if you try to figure out what's going to happen 5 years from now, based on what's happening today, it's not accurate. Because in that case, you say so many other factors are going to influence the demand. So forecasting, we have two types of forecasting. Short-term forecasting, we do this. We are projecting the past into the future. Short-term, to figure out what's going to happen 2 or 3 months from now, yes. Projecting the past into the future is going to work. Long-term forecasting is not going to work. So in that case, what we use experts, we use other types of forecasting, qualitative forecasting if you want. But for short-term, yeah, we can use, as I said, projecting the past into the future. Back to this one. So there are two versions of the problem. One version of the problem is if I give you a demand pattern, and then I say, figure out what is the best production plan. Obviously, in this case, it's clear-cut, but sometimes it's not as clear-cut. So there are so many different solutions you can try. Let's go steady up to this point, go down, then up. Somebody's going to say, let's try a little bit earlier and later. So to make the long story short, if I give you just a production plan and ask you to figure out the best, so if I give you a demand pattern and ask you to figure out the best production plan, this is one of the handouts I passed, which is pages 446 to 453 from the textbook, aggregate and master scheduling. It's done using Excel. That I'm going to do next week, and I'm not going to hold you responsible in an exam because this is difficult, but I'm going to show you how it is done next week. What I'm going to do today is the prerequisites. I'm going to do today, this is next week, and as I said, I'm not going to ask you to do something like that in an exam. It's hard, it's difficult. But what I can do today is the simpler version. The simpler version is to give you some data, and I ask you, if I tell you, apply a levelized plan, or apply a matching plan, what is the cost? That is a simple version. If I don't ask you to figure out what is the best plan, instead I give you the plan, and I say, just compute only the cost of this plan for me. So that's the simple version of the problem. We're going to start right now and we're going to continue next week. So let me take a numerical example, just a numerical example, and I'm going to walk you through the steps of computing the cost of a plan. So the first step to understand production planning is not to figure out what is the best plan, but to compute the cost of a plan. So we're going to solve two problems. The first one is cost determination of a matching plan. So that's what we're going to do next. I'll give you a plan, I'll tell you it's a matching plan, and I'll ask you to figure out what is the cost. And the second question will be cost determination of a levelized plan. Now, I gave you here the advantages and the disadvantages. So for the first one, for the matching plan, let me be specific. What type of costs are we factoring in the matching plan? In a matching plan, we have two types of costs. We have hiring cost and layoff cost. I'll explain the costs for the levelized later. So for a matching plan, remember, in the matching plan, we always produce what the demand is. The demand is high, we produce high. The demand is low, we produce low. By adjusting the production level, high, low, what happens? We're continuously fluctuating the workforce. When we increase the workforce, we hire. When we decrease the workforce, we lay off. So we have to be knowing the cost. So let's assume we have given numbers that the hiring cost is $100 per employee. And as I explained to you, what is the practical allocation of this number? Why do we pay money to hire? Training. And the layoff cost, let's use a different number, so let's use 150 for this one, is some type of severance pay. So the problem will be the following. So if I give you, that we'll do later. So today, right now we finish on this one. So if I give you a plan, a demand plan, then we have to figure out the cost. Now, how in real life, how often does the demand fluctuate? Depends on the type of product. In some cases, every day. In some cases, every week. Now, if you have an industry that is like a consolidated industry with many plants and so on, if you read textbooks in operations management, they usually use as a base period 1/4 of a year. Why do they do that? The reason they use as a base period for forecasting and demand planning and so on 1/4 of a year is because of their financial reporting responsibilities. Big companies have to report their financials quarterly. So what they do, since they have to report financials quarterly, they also do production planning quarterly. It's a simplification. Because as I said, the time period, the base period by which the demand fluctuates is not the same for all industries. For some industries it can be daily, which is an extreme, but sometimes maybe weekly, maybe monthly. But let's assume we use as a base period 1/4. So let's assume that we have a product and the demand is given quarterly. So we break down the demand by quarter to get a full year. In units. So we're given, and assume that this pattern is just a numerical example, and assume that this pattern repeats itself. So for a full year, we broke down the demand into quarters. So in the first quarter, the demand is 200 units of this product. The second quarter is going down, then 200. Third quarter going up to 3, and fourth quarter going further up to 400. Then if it repeats itself, it's going to go 200, 100, etc. So this is a demand pattern that fluctuates on a quarterly basis. So the base period in which we have a change is a quarter. What other information do we need besides the cost to figure out the numbers? We need 2 additional pieces of information. So one additional piece of information that we need here is the productivity of each employee. So let's assume here that we say each employee produces 50 units per quarter. Another piece of information that we need is starting conditions. So when we start, assume no inventory and 6 employees at the beginning of the year. Now the question is, given all of this information, what is the annual hiring and layoff cost of a matching plan? So all of this is given, and the question where we have to answer is the following. What is the total, so let me write the question here. What is the total annual hiring layoff cost of a matching plan? Okay, what I'm going to do is I'm going to walk you. This is a relatively simple problem from a computational standpoint. So I'm going to walk you through the steps, and then I'm going to ask you here in class to do an example, a numerical example to understand. So let's start with this one, matching plan. So this is the key word. So if we are dealing with a matching plan, what do we know as far as the production? The production will always be equal to the demand. So if I have to save time here, I don't need a separate column for production, because here we can put, this is the demand, but it's also equal to P. So D equal P, demand equal production. Why? Because that's the definition of a matching plan. The definition of a matching plan is that each quarter we produce exactly what the demand is. So there is no need for me to duplicate a production, to have a production column. It's identical to the demand. What is of interest for me to know is for each quarter, how many employees I need. So in your column here, employees needed. So what I have to do, for each one of the 4 quarters, I have to figure out how many employees do I need. How do I determine that? Here is the key information. Look at this number. The number I circled. Each employee produces 50 units. That is given.
No, but demand equals personnel, right? That's what the P
No, P is production. Demand equals production. So let me write it.
6.
divided by 200.
4.
Okay, let's take the first quarter. In the first quarter, I have to produce 200 units. Each employee is producing 50. So how many employees do I need?
4.
4. Okay, so let's do the rest. So we have to do it 3 more times. 2,
6.
8. Okay, so that's the first piece of information. So if I'm told, if I'm given the information of how productive each employee is, and I know how many units I have to produce, obviously it's a straightforward calculation to figure out the number of employees. But what I'm interested in, because in this problem we try to compute total hiring and layoff cost, is I want to figure out the changes in workforce going from one quarter to the next. So let me, in each quarter, I'm going to have 2 additional columns. Employees hired and employees laid off.
Too high.
Okay, something which is critical. At the beginning of each quarter, I have both options, but it's, at most we're going to do one. If we need more people, we're going to hire. If we need fewer people, we're going to lay off. But we're not going to do both. But again, one of the 2 numbers will always be a 0. In some extreme case, maybe we're perfect. We have exactly what we need coming from the previous quarter. But most likely, one of the 2 needs to be adjusted. But we're not going to hire and lay off at the same time, because one implies a surplus, the other one implies a redundancy. So, the other way around, or a shortage. So you cannot have a surplus and a shortage at the same time. It's either one or the other. So, for example, when we start, look at what the problem says.
We need 2
what
employees.
The problem is giving us is we have 6,
Right.
but we only need 4.
Half
so at the
one.
beginning of the year, what should we do? Lay off
2.
So this is 0, so we go there at 2. Why? Again, which is driving? Which piece of information is driving all of this? This number. We start the process and we already have 6 employees, but we only need 4. So that's the reason, instead of me giving you formulas, it's always what we have versus what we need. So what we have, 6, versus what we need, 4. If we need fewer than what we have to adjust downwards. So we lay off 2. Actually, if you want, I can put a 0 there.
Right.
So as I said, one of the 2 numbers here will always be a 0. In a perfect situation, both of them will be zeros, but one of the 2 will always be a 0. So this is, again, which piece of information drove the 2 there? This one, the 6. We had 6, but we only needed 4. Now look at where advance time by 1 quarter. We find ourselves at the end of the first quarter. So at the end of the first quarter, we end the first quarter with 4, but we only need 2 in the second quarter.
We need to
what should
lay
we do
off.
at the beginning of the second? Lay off
We need
2.
to lay off 2.
You see, it's always looking at what we have
Now we need
versus
to
what we
hire
need.
4.
So we find ourselves 3 months later, at the beginning of the third, end of the second quarter. We have 2, we need 6. Now we need to go the other way.
Yeah, hire 4.
And then we advance time 3 more months. We find ourselves there, end of the third, beginning of the fourth quarter.
We need to
We
hire
have 6, we
2
need 8. So 2 more.
and 0.
That's it. So now let's wrap it up. So what we do is totals. We need, remember, the question here was the total. What is the total annual cost? So now let's figure out the total for the year. So on the hiring column, 6. On the layoff column, 4. Yes, sir.
So the second where it says employees laid off and it's 2 for one into the second quarter, why is it 2? No,
Okay, why? Because we ended the first quarter with 4 employees, but we only need 2 in the second. So the difference is what we have to lay off.
Oh, I see.
Let's see.
It's always the current versus the previous one. We compare what we need now versus the previous one. That's how it
And
works.
no inventory.
So let me do it one more time.
Yes, please, Professor. Yes. On the number 6.
I see how it is. I see how it is.
Let's take it out.
You
Let's
see
do
it
it one
now?
more time.
You see it now?
Okay, as I said, let's do it one more time. Let's do it one more time. We have
I
time.
don't have to see.
So as I said,
No, we don't have.
at the beginning of each quarter, we have to take action. Either we need more people, so we hire, or we need fewer people, we lay off, or an ideal situation, we have exactly what we need, so we do nothing. But most likely one or the other. Either we need more people or fewer people. We always compare what we need versus what we have. When we start, what we have is given outside the problem. It's there. It's the 6. So you say you start this process by having 6 employees. But based on your production needs, you only need 4. So in that case, you need 4, you have 6. You have to lay
6
off
minus 4.
the surplus. Now you find yourself 3 months later. At the end of the first quarter, 3 months later, you have 4, but you only need 2 in the second quarter.
You need to
So you have
hire.
to lay off the difference, 4 minus 2.
I mean,
Now I get it.
Now you get yourself there. Look at where is my finger.
2.
End of the second quarter,
That's
beginning
4.
of the third. So now you have 2 at the end of the second, but you need 6 for the third. So you have to hire the difference,
That's
4.
4. I get it.
Oh, I get it.
Now you find yourself always advanced by 3 months, 1 quarter. You find yourself, look at where I'm pointing. At the end of the third, beginning of the fourth quarter, you have 6, but you need 8. So you hire 2 more. And that's it. We just do a full year. We say what is the cost of a full year. So what we're going to do right now, we're computing the totals. So on the hiring column is a 6, on the layoff column is a 4. And here's so the total cost, look at these numbers. Now I'm going to factor in the cost per person. So for the year, so we have hiring cost plus layoff cost. On the hiring cost, how many people are we going to hire throughout the year? 6. And the cost per person is up there, 100. Plus, on the layoff column, we have 4 for the year,
150.
150. 1,200 per year.
Correct.
So that's what I was trying to tell you, that when it comes to a matching plan, the information, what I'm going to ask you to do is, next week we're going to do a situation where we have to figure out what is the plan. But I'm not going to ask you questions about that. That's too hard. But the question that I'm going to ask you is, if I give you a matching plan, the question is, what is the cost? So for a matching plan, the only thing we do is we hire and lay off people, because we adjust the workforce going forward. So the cost is always determined doing this. That means for each quarter, we figure out how many employees we need. And then, how do we determine the adjustment? We always compare what we need versus what we have. If we need more than we have, we hire. If we need less than we have, we lay off. And then we go advance 1 quarter. We do it again and again and again. So again, the simplest way to understand is just to replicate. Just erase those numbers and do it from scratch, and then you will see how it works.
So if you give us something like this, are you going to give the demand?
Yes.
Okay.
Without the demand, this cannot be done. So I'll give you the demand and all the other. So what type of information I'm going to give you? So the information that you need to be able to do it, besides the demand, obviously, is starting conditions. How many you have? What you have? Productivity. How many units one employee can produce, and cost.
Okay.
Without all of this information, it cannot be done.
Okay.
So you need at least all of this information for this problem to be done. Okay, what I'm going to do is I'm going to stop here.
Okay.
So next week, as I said, I'm going to continue with the other plan